Let's watch that video. Let's watch it now. Last time, let's watch that video. Let's watch it now.
Hello and welcome to my channel. In today's episode, we'll install the Armbian Ubuntu Jammy microsd card from part 1 into the LaPotato SBC or single board computer and add the assembly to our LAN. We'll boot the SBC, complete the installation of the operating system, log into it via SSH from my Linux Mint desktop command line, and then run a few simple Linux commands before I shut it down. But first we give thanks to the products or services that make these videos possible. Instant coffee crystals and mini chocolate donuts. Yum, yum. The LAN switch. Setting up these old LAN switches isn't too difficult. In this case, it's a Netgear WGT624V3, and I was able to Google and download the PDF manual easily. Running through the hardware for this segment, we have the LAN switch, the wall wart that powers it, and Ethernet cable that will connect to the desktop, and a power strip so I can power the switch and the LaPotato single board computer separately from the desktop. So plugging everything together, here it is sitting on a cardboard box. On the back of the switch is a factory reset, which I use to restore the factory settings, and a WAN port. Back in the day, I used this with a cable modem. The 4 ports for the LAN, the local area network, and the power input. So I power it up and I don't get any port number 1 activity light. I can't connect to it with Chrome. The network GUI on my desktop showed that the LAN cable was not connected. I try another cable. Then my video card locked up and I had to reboot my desktop. And it was suddenly there, activity on LAN port number 1. I probably could have used a shell and some network manager tools to bring the Ethernet up on the desktop side of things. And here is the switch being powered up after my desktop is rebooted. So here's Chrome, and a login to the default 192.168.1.1 router address, entering the router username and password, the welcome screen, and here I'm going to skip the wizard and configure it myself. Now to advanced wireless settings, unchecking enable wireless router radio, apply, waiting for the update to complete, and now attached devices. And in the attached devices list, there's my desktop. And that concludes this segment. In this segment, we will add the LaPotato single board computer to the local area network and boot it. First, we review the hardware to be added to the LAN, the LaPotato single board computer, and an Ethernet cable. You may recall that this series is focused on headless operation. Here is a phone charger that meets the power requirements for LaPotato. This one is rated for 2 amps. And a micro USB cable to power LaPotato. Next, I'll insert the SD card written in the previous segment into LaPotato. Removing the single board computer from the box. Here is the USB adapter from the previous segment. The SD card is still inserted. Now the LaView Class 10 32 GB SD card is removed from the adapter. Flipping LaPotato over, I can insert the SD card into the SD card socket. Now I push the SD card into the socket until it clicks. The socket has a spring latch, so a push and click locks the SD card into place, and another push and click ejects the SD card for removal. And now the SD card is in. As I was getting ready to add Le Potato to the LAN, I noticed the Ethernet cable had a lot of coil memory from being wrapped up so tightly. I exercised the Ethernet cable a little and then cable tied it to the power cable and plugged them both back in. So here I plug the Ethernet cable into the Le Potato RJ45 jack and the USB power into the Le Potato USB power port. This shows everything, including the phone charger. Here's the existing router/LAN from the previous segment. The phone charger goes into the power strip, the Ethernet into port number 2 of the LAN, and here is a short video of the assembly process. Now here we go, plugging in the power. Looks good, LEDs are flashing. Now I go over to Google Chrome on my Linux Mint desktop. Here I log into the LAN router at the default private.quad block address 192.168.1.1. The router page pops up an authentication login. Now I wait patiently for the Le Potato single board computer to pop up in the attached devices list. And here it is. I sped up this montage a little because I was distracted by a few other things. Feel free to set the YouTube speed control to preference or pause. Basically, I ping it, SSH into the root account, perform some system administration for the installation, add a user, log out of the root account, log back in as the new user, run a few apps, and then shut down the system. It's worth noting that the shutdown-H option should halt a system, but Le Potato will reboot after about 7 seconds. Be sure to power off the board in a timely fashion, or the file system could be corrupted. It's a trade-off between Internet of Things reliability and the risk of not realizing that it's going to wake up again and all the repercussions of that. There might be a system setting to do an actual halt versus a reboot. The LED sequence is red is power on. When the device boots, and runs for that matter, the green LED is solid and the blue LED flashes. So it's safe to power off Le Potato when the red LED alone is on. According to the schematic, block location A, 4 and 5, on page 3, red is power on, and it is illuminated by power, a resistor, and ground. It is not signal controlled. And if we look at schematic block locations CD3 on page 4, blue is GPIO 15, GPIO AO_2. Note the AO, or always on bus, within the system on chip. According to the device overlay file, the blue LED is a heartbeat signal. Green is GPIODV_24 sys LED. The device overlay file refers to this as both a system LED and a panic indicator. I am not sure what the difference is. Maybe it flashes if the system panics. There might be a way to safely induce a Linux kernel panic and note the behavior. If you are curious about the time to boot, I measured 38 seconds from power on to the SSH daemon responding to the SSH client. The shutdown command takes about 4 seconds. I am pleasantly surprised by the quality and value of the LaPotato single board computer and the armbian build of Ubuntu Jammy. There have been no issues whatsoever in the process of setting up the software, booting the board, and running it. So at this time, we've wrapped up configuring LaPotato with Linux, adding it to a network, configuring the operating system, and running a few basic commands. The next 2 videos are likely to be a break from LaPotato. The first video is going to be a short one, a simple printer repair, and the second video will be a surprise. Then we'll be back to LaPotato. Now that we have LaPotato and my Linux Mint desktop on the LAN and communicating, we'll move forward with some software design and development. My notes so far imply that it will be a set of videos covering data on LaPotato, a data producer, a data aggregator, an HTML5 compatible WebSocket server, and data on the desktop, an HTML5 canvas web page that renders the WebSocket data. It's one way for now, and there is no data fusion. Ultimately, this will have a command path from the desktop. HTML5, JavaScript, and WebSocket are bidirectional, as well as an internal control path. The aggregator will become bidirectional and perform actions on its own. For example, detecting off-scale sensors and running a PID, proportional integral derivative control algorithm. As always, thanks for watching.